Welcome to Structural Engineering Online. In this lecture, we will learn how to determine the degree of static indeterminacy of a rigid frame. So first of all, we must understand what is a rigid frame, and then we will come to the degree of static indeterminacy. A rigid frame is that frame in which the members are connected through rigid joints. Now what is a rigid joint? So for the rigid joint, we can say that this will be having the angle unchanged. So if the angle initially, that means before loading, was 90 degree, then after loading also it will remain as 90 degree angle. Similarly, if the angle between two members is 30 degree, that will remain 30 degree after loading. Or if it is 120 degree, that will remain as 120 degree after the loading. That means the angle between the members will not change, it will remain constant after the loading. That joint is known as a rigid joint. And other than rigid joint, we have the flexible joints, which you have seen already in the case of the truss. All those pin joints will be considered as the flexible joints. So we are talking here about the rigid joints. So in that case, we have got this information that the angle will not change between the members after the loading. This is one thing that we should know, how the members will behave after loading. Now the next thing is the indeterminacy. So in the case of indeterminacy, we have to learn whether we are able to find all its unknowns. Now what are the unknowns? The unknowns in a structure are the external unknowns, which are coming from the support reactions, and the internal unknowns, which are the forces in the members or the moments. So we will talk about these things in detail and with the help of some examples also with different types of rigid frames. But before coming to the degree of static indeterminacy, we must also know about the stability of a structure. Stability of any structure, whether it can take the load or not. So if their structure is stable, then we will calculate its degree of indeterminacy. Otherwise, there is no need, because it will not be able to take the load. So in that case, there are three conditions which we must check for any structure. Number one, that the reactions which are coming from the supports should be greater than or equal to the equations. So R is equal to reactions, which are external reactions, and E is equations of equilibrium. And I think all of you know that these equations of equilibrium are sigma fx equal to 0, sigma fy equal to 0, and sigma m equal to 0 for a two-dimensional structure. And these are very important equations of static equilibrium, which we should know. Okay. And the second condition, that the reactions should not be parallel. Okay. Reactions not parallel. This is second. And the third is that non-concurrent. That means all the reactions should not be meeting at one point. The reactions should not be parallel. All the reactions should not be parallel, and they should not be concurrent. So these are the conditions of a stable structure. Okay. Now we'll come to this degree of static indeterminacy as you know that there will be unknowns in the structure, which are the support reactions and the internal forces, which are axial force, shear force, and the bending moment. So these are the unknowns. So in general, we can say that internal, that is, so degree of static indeterminacy, in general, we can say that this will be measured in terms of the reactions, or in general, you can say that the total unknowns right, if these are equal to the equations available, then we say that this is determinate. And if the unknowns greater than the equations, then indeterminate. And if the unknowns are less than the equations, then it is unstable. Okay, so if unknowns are less than equations, then it is unstable. Okay, now we will see in our rigid frame how we can calculate the degree of static indeterminacy for these rigid frame. We will take some examples in a nice way. If you look at this frame is having three members, and which are connected with these rigid joints at B and C, and also at A and D there are fixed support. So we must know how many reactions are possible at the supports and how many unknowns will be attached with each member. So we can quickly say, okay, here we will have one vertical, one horizontal, one moment. Here also one horizontal, one vertical, and one moment. So three reactions at the fixed support, that's as we already know. And every member, because these are all rigid body, so every rigid body will have three unknowns: one axial force, one shear force, and one moment. So we can say that there will be 3 plus 3, 6 reactions which are unknown, and then we have three members, so every member will have three unknowns. So you can say that there will be 3 plus 3 plus 3 is equal to 9 unknowns which are internal. So external unknowns and internal unknowns, and then how many equations will be available for us. Based on that, we will be calculating whether it is determinate or indeterminate. And one thing is very clear, that this is a stable frame because all the reactions are not parallel and all the reactions are not concurrent. So first we can say, okay, we will be calculating here the unknowns. So in this case, we can say, okay, internal unknowns are internal plus external. Okay, here internal we can say 3 into 3, each member has 3, and external depending upon the support types. Here we have these two fixed supports, so every fixed support will give you 3. So we can say that 3 plus 3. Okay, so these are the only unknowns here in this question. So we can say 9 plus 6 equal to 15. Okay, so we can say quickly that the unknowns are 15. Now how many equations are possible for solving this structure to find these unknowns? And for that we have to look at these rigid joints, because at every rigid joint you will get 3 equations. Okay, so in that case, the equations equal to 3 into the joints, right? 3 into the joints. And in that case, we can say that it will be 3 into joints A, B, C, D. So it is 3 into 4 equal to 12. Now we can quickly say, okay, the unknowns are 15 and equations available are equal to 3. So we can calculate the degree of static indeterminacy equal to 15 minus 12 equal to 3. This is the way to calculate this degree of static indeterminacy in a frame. Here we can also develop a formula for that, and we can say that degree of static indeterminacy can be written as equal to 3m plus r minus 3j minus c. And these are the same thing as we have discussed here. M is for the members, R is for the reactions. So M stands for members, R equal to reactions. Okay, then J equal to joints, and C equal to the number of condition equations. Okay, number of condition equations due to internal hinge, right? Condition equations. Now we will solve some questions with this internal hinge, and then you will be able to understand all these things very clearly. If you see in this second example here, we can easily find out the reaction component, and you can see here that there is one internal hinge also. So we see here that this is giving you this type of reactions, horizontal, vertical, and the moments. So we can calculate here the degree of static indeterminacy for this, because we need how many members are there, how many reactions are there, how many joints are there, and how many conditions available for us. Okay, so we count here M. How many members? AB is one member, BC is one member, and CD is another member. So we have M equal to 3. Then how many joints? Okay, joints also we can calculate. A is one joint, B is one joint, C is one joint, D is one joint, and we will consider these rigid joints plus the joints which are at the supports. This hinge we will not consider here in the case of this rigid joints. So we have joints equal to 4 here. So M is equal to 3, joints equal to 4. Now reactions, how many reactions? Are equal to the support reaction. So 3 plus 3, 6. Now we also check how many equations of condition. Now equations of condition, if you see here, you can quickly say that how many members are connected there. So in this case, you can say this hinge, internal hinge, is connected with 2 parts or 2 segments or 2 members here. So we can say that C will be equal to 2 minus 1. Okay, right. So we calculate here the degree of indeterminacy. So here we have C equal to 1. So DSI we can calculate as 3 times M. So 3 into 3 plus R is equal to 6. Then minus 3J, J is equal to 4. And then minus C, that is condition equations 1. So we can calculate this as 9 plus 6 minus 12 minus 1, and we get this value as 15 minus 13, and this is equal to 2. So this way we have got the degree of static indeterminacy of this rigid frame where there is one internal pin. Now we will look at another question. Here we have something which is like a box. You see here, it is closed, it is not open, just like a loop. If you start from E, then go to B, C, F, and then you can also come back to point E. This is just like a loop in the structure, or closed box we can say. So here also we can apply our same equation for static equilibrium, and then we can say, okay, here we have reactions, vertical, horizontal, and the moments here. And if we look at our equation, which is same as degree of static indeterminacy is equal to 3m plus r minus 3j minus c, though we can write here degree of static indeterminacy is equal to 3 times m plus r, these are your unknowns, minus 3 times the joints, and then minus the equations of conditions. So we can see here that m equal to how many of these members are available here. So we can see in this question here we have m equal to 1, 2, 3, 4, 5, 6. M is equal to 6. Joints equal to 1, that is A, E, B, C, F, D. Joints also equal to 6. And how many reactions? R equal to 3 plus 3 is 6. And there is no internal pin, so C is equal to 0. So now we can calculate this degree of static indeterminacy as 3 times m plus the reactions, which are 6, minus 3 times j. J is 6, and then C is equal to 0. So we can quickly calculate this value as 18 plus 6 minus 18, and when we simplify, this will give you the value as 6. So the degree of static indeterminacy of this frame is equal to 6. Now what does this degree of static indeterminacy tell us? That means we need some extra 6 equations to solve. And if you want to learn more about the stability and determinacy of structures, you can see our previous lectures which are available on YouTube. We will provide the link in the description. Okay, now we come to another equation. The frame is very much similar. The only difference is that there is one internal pin. So we will solve it in a similar way, and we will take care of this internal pin here. So here we have this additional thing that C is equal to 1. Okay, because it is connected with 2 parts, so it will be equal to 2 minus 1 here. 2 minus 1 for the pin. So we can calculate here in the similar way degree of static indeterminacy 3m plus r minus 3j minus c. So here we substitute because these joints and the members are same. So it will be same as 3 into 6 plus the reactions same. We see here 3 reactions here, 3 reactions here. So total reactions are 6, and the joints A, E, B, C, F, D. So we have here the joints also equal to 6. So 3 times 6, and condition equations 2 minus 1, that is C is equal to 1. Remember that you will not count this hinge as a joint. Okay, now we simplify this, and this gives you 18 plus 6 minus 18 minus 1. So this is equal to 5. Now you can see here that once we introduce one pin in this frame, the degree of indeterminacy is reduced by 1. In the previous frame here, it was 6, and just by introducing this, the degree of indeterminacy has been reduced to just 5. Okay. Now we go to another frame here, and you see here there are 2 internal pins. The same box which was given here it was 1 pin, and now we have here 2 internal pins. Okay, the joints will remain the same, reactions will remain the same. We will see here 3 reactions. Okay, joints will also be same, but look at this internal pins. This internal pin will give you one condition, but be careful at E, because E internal pin is connected with your 3 members, right? So internal hinge at E is connected with 3 members. One member is EF, another member EB and EA. So here we can say that C will be equal to 1 from here, and C will be equal to 2 from here. As I told you that it will be equal to the number of members connected with the internal hinge minus 1. So from these 2 internal pins, we have to count the value of C. So it will be 1 plus 2. So the value of C is equal to 3 in this case. Okay, reactions equal to 6, members equal to the same members as you have seen in the previous one, M is equal to 6 and J equal to also 6, right? Okay, we will consider only those joints which are rigid joints. Okay, then we see here the degree of static indeterminacy will be calculated in the similar way. 3m plus r, these are your total unknowns, minus 3j minus c, and these 3j and c are your equations which you can apply for solving. So here we can substitute these values. So 3 into m, that is 6, plus r is 6, minus 3 times joints which are 6, minus the condition equations which are 3. So you can say that quickly, when we simplify this, it is equal to 18 plus 6 minus 18 minus 3, and this comes out to be 3. So in this case, we have solved for this question also, that the degree of static indeterminacy in this case, when we introduce 2 internal pins, that will be equal to just 3. That means 3 additional equations will be required for completely solving this structure with external unknowns, internal unknowns. Now what is happening at the internal pin? As you know that internal pin will not give you any moment. There will be only horizontal and vertical forces, and there will be no moment. So you can say that moment at E will be equal to 0 here, right? Moment at E at this point will be equal to 0. So in these members, which is EF, EB or EA, there will be no moment at this point. So that is the thing. Now we come to this example, which is the last example for this lecture. And here you can see we have these two loops here. Okay, but the internal pin is connected with 4 members. That is the only new thing which you can see here. Otherwise, box or the loop you have seen in the previous questions also. So we can calculate here the degree of indeterminacy in the similar way. DSI, same formula, 3m plus r minus 3j minus c, but we have to find the values of these m, how many members, how many reactions, how many joints. Okay, so here vertical, horizontal and moment, vertical, horizontal and moment, vertical, horizontal and moments. So we know the values of these reactions, 3 plus 3 plus 3, 9. And how many members are there? If we count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So m is equal to 10. R equal to 9. J equal to, now you count J, starting with this A, B, C, D, E, F, G, H, I. Here E will be considered as a joint because it is connecting with these members and we are counting them as separate members here. So the joints are equal to 9 in this case. And how many conditions of equations are available now? As we told you earlier, then look for the members. How many members are connected in this case with the internal pin? So here you can clearly say that EB, EF, EH and ED are connected. That means 4 members are connected. Therefore, C will be equal to 4 minus 1, which is equal to 3. Now we will substitute these values in this equation. So degree of static indeterminacy is equal to 3m. So 3 into 10 plus r equal to 9 minus 3j, j equal to 9 minus c, and c is equal to 3. So this way, when we simplify these things, we get 30 plus 9 minus 27 minus 3, and that is equal to 9. So this way we have determined the degree of static indeterminacy for these rigid jointed frames. I hope this lecture has helped you to understand how to calculate the degree of static indeterminacy of rigid jointed frame. You also learn about the stability of the structures. If you want to know more about that, you can see our previous lectures about stability and determinacy of structures. So if you have got some benefit from this lecture, please click on the like button and share it with your friends so that they can also get the benefit from this lecture. And you can also subscribe to our channel so that in future when we upload any new video lecture, you will get the information about that. Thank you very much.